Hi everyone, this is Hardik from fuzzing.in. Thank you for watching my videos. In today's video, we are going to see what is OSS-Fuzz and how can we use it locally, how can we set it up, and how can we fuzz various open source software using OSS-Fuzz. So let's start. Been following my previous videos, you know that to fuzz any open source software, we need to follow a specific set of instructions. First thing is that we need to download the source code. It can be either from GitHub or GitLab or from the site. Second thing, we need to instrument this code using fuzzing wrappers like AFL Clang or AFL GCC or AFL Clang Fast. And after we have instrumented the program, we need to download the corpus. For downloading corpus, we either need to do Google search or we need to visit various projects on the GitHub or other sites, and we need to collect the corpus and we need to like minimize that, and then we need to start fuzzing. Now, suppose a software gets regular update. In that case, it is a mundane task where that every time we want to fuzz a software, we want to have the latest source code of that software. We need to go to the GitHub or that particular website. We need to git clone the repo, then we need to instrument the program again, and then we need to again collect the corpus or need to copy our existing corpus to the new directory structure or whatever we are doing, and then we need to do the fuzzing. Now on a single system, it is a very difficult task. We just cannot keep updating all the software because it will take a lot of time. So what Google did is that they came up with a infrastructure on it or an automated way of fuzzing various open source software, where we can simply integrate our software with Google's OSS-Fuzz, and it can automatically fuzz it on the thousands of systems. So they call it as a cluster fuzz, and this project is called as a OSS-Fuzz. In OSS-Fuzz, what they do is that you simply need to write some some fuzzers for that particular OSS software, and you need to integrate it with the OSS-Fuzz. There are very specific steps which we will be looking as we go forward with this OSS-Fuzz video series. So just to summarize, what OSS-Fuzz does is that there are a set of projects which are like various open source software like OpenSSL or libtiff or libgd or ImageMagick, etc. And they have a specific set of configuration. You need to generate some files, some configuration files. You need to write some fuzzing harness. And what OSS-Fuzz will do is that it creates a Docker image. You basically need to create this configuration file where you need to list down all the dependencies. You need to list down where to get the corpus, and it will do it in an automatic manner. So what it will do is that it will create a new Docker image. It will download all the dependencies. It will compile your program. It will instrument your program with either with AFL or either with libfuzzer or any other supported fuzzers. And then it will start fuzzing that. Now this entire process is automated. So whenever a crash is found, a bug will be automatically created, and a developer or maintainer of that project can track it down. So it has many advanced features, but the idea of this video is to give you a general idea of how can we fuzz any open source project using Google's OSS Fuzz on our local system. And in the later videos, we can see how can we integrate our open source software with Google OSS-Fuzz. OSS-Fuzz is hosted on GitHub, and the URL for OSS-Fuzz is github.com Google/OSS-Fuzz. When you open this URL, you can see that this is the direct structure for this project, and you can see that there is a general overview over here. So you need to write fuzzer, that is first step. Then you need to commit build config. I mean, you need to commit those specific file to your projects on the OSS-Fuzz. And what OSS-Fuzz will do is that it will sync and build all the project related dependencies, entire project on the cloud, and it will basically uses cluster fuzz, which is like a fuzzer with like various systems, lot of systems. It will fuzz them on like thousands of systems, and when it finds any crash, it will file bugs and it will verify the fixes. So there are this entire process is automated, and there is a detailed documentation which you can go and you can read it over here. And if you see the structure of the OSS-Fuzz directory. So there are like there are few directories. One directory which is called infra, it has all the needed script which we'll be needing going forward. So the mostly we'll be using helper.py in this video, and there are various other files which we are not going to use right now. Then if you go to the projects directory, you can see that it is all the OSS-Fuzz project which Google supports. So all this project which you see are fuzzed by OSS-Fuzz on a regular basis using cluster-fuzz. For our demo, we will simply use a library which is libtiff. Let's see if it's there. Yeah, okay, it is over here. And what happens is that each of this directory denotes to a specific open source project, as you can see it over here. And each of this directory has a Docker file. When you open this Docker file, what you will see is that it has some instruction like you need to download a base OSS-Fuzz image, and then what it does is that it runs apt-get update, and it install autoconf and libtool and cmake and nsm, which are required to build various libraries. And then it will use git clone to clone the libtiff. Then it will do git clone for zlib, and it will do git clone for libgpg turbo, gbgit, etc. So this is the main project which you want to fuzz, that is libtiff, and these are the dependencies which will be used by libtiff. Then you can see that there is another docker command, that is add, and what it does is that it downloads the AFL test cases from the AFL website. If you recall our previous videos, or if you have been to any of my fuzzing workshop, you can notice that this is the site which is maintained by the author of AFL, and it has a lot of image test cases. So these are the AFL test cases. Basically, this zip file contains all the image test cases like TIFF or JPG or GIF and other file. So it downloads that AFL test cases, and then you can also notice that there is one more instruction to download dictionary file. So this is the dictionary file for TIFF, which contains various tags using TIFF file. Then it sets up one working directory, that is libtiff, and then it copies build.sh to source directory. Now let us go ahead and see what does build.sh contains. So if we see it over here, so basically we see that there is one path, that is contrib OSS-Fuzz build.sh. Now the thing to note over here is that libtiff is actually hosted on GitLab and not on the GitHub. So if you go to the contrib directory, and then you will notice that it has a directory name OSS-Fuzz. So if you go to that, you will see that there are two files. One is build.sh and second one is tiff_read_rgb_fuzzer.cc. So this is the fuzzing harness. We will come to this later, and let us go ahead and see what's inside build.sh. So when we go and see the build.sh file, you can notice that it has lot of build instruction to build zlib, libjpg turbo, like there is a configure command, there is a make command, there is make install, and turbo where it uses cmake, then there is make install, then there is a libgbgit, so it is some specific architecture related build command over here, and then you will notice that here are the instruction to compile the fuzzer, a fuzzing harness over here. So you can see that it goes to that particular directory, and then it uses like C compiler, and to like it will use this particular command, that is fuzzing engine, and then it will compile this file using, and these are the like dependencies which it uses. So it will basically generate a compiled binary, that is that is tiff_read_rgb_fuzzer. Over here you can see this is the output file. So this is actually fuzzing harness. When we run this file, it will fuzz libdiff. And then you can also notice that it creates a directory name AFL test cases, where it unzips the provided test cases. It basically looks for all the TIFF file inside AFL test cases, and it copies them, it moves them to a directory called TIFF over here. So these are the build instruction, and now let us go ahead and see what does this fuzzing harness contain. So if you open this fuzzing harness, that is tiff underscore read underscore rgb underscore fuzzer.cc, you will notice that it follows the libfuzzer harnessing style. When it's say like libfuzzer harness, where it uses that function. If you are not sure what libfuzzer is, that I will suggest you to go to my channel and look at the libfuzzer video. So it expects two parameter over here, data and size of this data, and over here it looks for like some environment variable just to avoid some issues with libgpg turbo sims. And over here you will notice that it basically takes the data and the size of the data, and it will create a tiff stream. Basically what it does is that it takes the data and it takes it as a stream. It will convert it to like a tiff file, and over here it will like take image width, image length, and there are some checks, like if size is like too much, like if it's more than max size, and we'll simply return, there will be no fuzzing. Then there is some file size over here, it will notify the file size. So again, there are some sanity checks over here. If buffer size is equal to 0, or if it's more than like max size, it will return. And then you will see that there are some like safe multiply, which multiplies image with, I think, with 2. Then again there are some checks, like if width or tile width is equal to 0, or if it's like it's more, like if it's more than max size, then it will return. We don't want to fuzz. Otherwise it will do a malloc. It will allocate some memory, and then it will call this particular function. So this is the function which is getting fuzzed over here, that is tiff read RGBA image with the provided data over here. This is tiff file, this is width, height, raster, and 0, and then it will free up the raster over here and it will return. So and you will see that there is actually a main function over here. Generally libfuzzer harness doesn't have the main function. This is like kind of if you want to like debug something, that is what I'm guessing out for this. And yeah, so there is like if defined standalone, right? So that is why it's used over here. So this is the simple harness, and the function it is fuzzing, as you might have figured it out, is this tiff read RGBA image. So this is the simple harness, and with that, now that we are comfortable with what, how does it compiles, how does it fuzzes, let's go back to our libtiff fuzzing, libtiff directory on OSS-Fuzz. And we have already seen Docker file, we have already seen build.sh, and now let us go ahead and see project.yml. So this project.yml file will be there for each and every project. It contains some specific instruction, like you can see, like what is the home page for the libtiff. It is this libtiff.org. What is the language? It is C++. Who is the primary contact? So this is the primary contact. AutoCC is this sanitizer. So which address, like sanitizer or memory sanitizer or undefined behavior sanitizer you want to use. So it uses address, and the memory sanitizer is disabled. There seems to be some issue, so because of that you can see the note that memory sanitizer is disabled, and undefined behavior sanitizer is over here. Also there are supporting architecture, so it is supported on x86-64, that is 64-bit, and then i386. And the main repo is over here, so it is hosted on the GitLab over here. So these are the simple thing you will find in any of the OSS-Fuzz projects. So we have seen libtiff. Now let us go ahead and let's have a quick look at any other project. So I'm mostly focusing on the C or C++ project, but it supports Java as well. So let me see if we can look at, let's say, libgd. Okay, so we'll have a look at say libgd. This is another open source project. So if you go to the Docker file, you will see the similar instruction where it is downloading base builder, and then there is apt update, and it install autoconf, automake, etc. Then since this project is hosted on GitHub, so it is simply doing git clone over here. Then you will notice the similar command, that is, it is downloading if disk cases, it is like copying it over here. Then working directory is libgd, then it is copying build.sh to the source. So this is similar to what we have seen in libtiff. And now if we go to the build.sh, so over here also you will see that it has like similar instruction, like there is configure, it will run configure command, and it will do make, and then I think it will do okay, after configure it will do make, and then it will do make install over here. And then what it will do is that it will basically compile the fuzzer for different file formats. So you can see there is bitmap, there is 3D, there is GIF, there is JPG, PNG, etc. So it will basically compile those fuzzer. It will compile like separate fuzzer, and it will like create executable for them. And then from the if disk cases file also, what it will do is that it will try to identify all the bitmap or the GIF or the PNG and all the AP file, and it will move them to the separate folder over here. So this is just like a kind of simple logic over here. And then this is like another fuzzer, that is string fuzzer. This is again the lib fuzzer harness, where it will simply call this function gd image create true color over here. And then there are like stream dot pick value in array, all these things are over here. So these are like very specific function. There is gd image string, right? So these are the function which has been fuzzed over here. And there is parser target.cc. So I think this is the fuzzer. It will basically create the image for fuzzd format. So like we have seen that there are different file formats. It will basically create image for different like file format like bitmap or GIF, etc. over here, and then it will call image as it is basically creating the image, and after that it will destroy the image. Nothing too complex over here. And then there is project.yml over here, which contains like homepage, languages, primary contact, autocc, and main repo is over here. So if yeah, that is fine. So that is all it has. So now you understand, like if you go to any of this project, it follows a standard directory structure. There will be a docker file, there will be a yml file, there will be a build.sh, and this will be a general structure. Let's open any other random, let's say boring SSL. So there is a docker file, there is build.sh, these are the fuzzers, there is a project.yml file. So this is a very specific structure. Now what we can do is that we can see how can we use this OSS-Fuzz fuzzers, or how can we like create this kind of fuzzer on our system. So what we are going to do in this video is that we are going to see and like compile libtiff, and then we will try to fuzz it, and we'll see if we get any issue with that. So let's go ahead and see that. So first thing you need to do is that you need to run this command, that is sudo apt update. Once you do that, you need to install Docker on your system. So for that you will use this command, that is sudo apt install /y docker.io. When you run this command, you will see that on my system I already have it installed, but in your case, if you don't have installed, it will install Docker on your system. And after that we need to run Docker. To run the Docker, what you can do is that you can use this command, it is sudo systemctl enable docker -- now. It will basically install and it will run Docker on your system. After you have Docker working, you need to add your user to the Docker group, otherwise you might face some issues. So for that you need to run another command, user mode -a capital G docker username. So in my case, my username is Kali, that's why I'm using this command. And after that you need to clone the OSS-Fuzz repo on your system. So for that you will use this command, that is git clone, and then the URL for OSS-Fuzz, that is https github.com google /ossfuzz.git. Once you do that, it will clone the OSS-Fuzz repo on your system. On my system I already have it cloned, so that's why I'm getting this error. Now if you go to OSS-Fuzz repo, you will see that the same thing which we have seen on going to the URL over here, as you can see. So it will basically clone this entire repo, and it's actually not too big. So if you go to the projects, right, you will see all the projects which are Fuzz by OSS-Fuzz. And as we have seen, if we go to say libtiff, you will see the similar file. Let's see the build.sh. So it has like it is hosted on GitLab. So that's why we are seeing it. Let's see Docker file. So the same file which we have seen over here. So this is what it does. And now what we need to do is that we need to go to the OSS-Fuzz directory, and now we will see how can we like first we need to create the Docker image, and then we need to create the fuzzer, and then we can fuzz it. There are specific set of instructions. So first thing we need to do is that we need to create the specific image for our project. In this case, we are trying to fuzz libtiff. So we need to create a very specific Docker image for that. And there is a command. So you need Python 3 install on your system first. If you don't have, you can simply do sudo apt install Python 3. It will install. To use this command, that is Python 3, then make sure you run this command from the OSS-Fuzz directory. You don't change any other directory. Then there is a directory name infra. Then you have to run helper.py, build image, and libtiff. So when you run this command, the build image, what it will do is that it will create the Docker image for libtiff. So when you run this, you will get this like pull literacy base image. So if you have not updated your base image, you can select yes, but in my case I have used it very recently, so I'm just going with the default option, that is no, as you can see it on the capital over here. Now you can see that it is installing all the dependencies, like it is following that Docker file. Basically it is downloading the base builder, and it will run up get update and all the autoconf and all this thing. It will install libtool, etc. So this is going to take few seconds, maybe a few minutes, depending on the internet speed you have. So we need to wait. Now you can see that it is cloning the libtiff from GitLab on the Docker. So basically the URL given was this, but it is going to this. This should be the URL over here. That's why you are seeing it in the red over here. So it is cloning all the dependencies you see. There's zlib, there is libjpg turbo, there is gbkit. You can see it over here. It is downloading the test cases from the AFL site, which is like 2.488 MB. Then it is like downloading the dictionary. So this is what we have seen in the Docker file, if you recall. And now the working directory has been changed to libtiff. Then it is copying the build.sh to our source file. And now as a next step, we need to compile the fuzzers. So for that, the command is like almost similar. We simply need to change the parameter to helper.py. So previously we used build image. Now we are going to use build fuzzers dash sanitizer. So which sanitizer you want to use. So it can be like address, or it can be memory, or it can be undefined. And then the project name, that is libtiff. So if we press enter, you will see that it will basically compile the fuzzer, basically that harness program which we have seen, and it will like set up the environment for us so that we can run fuzzers. Okay, it is compiling all the dependencies over here. So let's wait for a few seconds, maybe a few minutes. Okay, now you can see that it is compiling libtiff over here, and you can see that it is like looking for all the tiff file from AFL test cases, and it is copying it to the tiff over here, tiff directory. So you can see, and then what it has done is that it has copied the dictionary file as well. Now if you go to the build directory, and if you go to the out directory again, you will see that it has a directory named libtiff. So let's go ahead and see what's inside libtiff. And here you can see that it has compiled our fuzzer. That fuzzing harness which we have seen is compiled over here as a fuzzer. There's a dictionary file, and this is the out directory over here. Now we will go back to our OSS-Fuzz directory again. And now what we can do is that we can run our fuzzers. So again, to run fuzzer, we have to run a command that is almost similar. We will use helper.py and we need to change the arguments. So this will be the command. So the command will be helper.py, then run fuzzer, and then dash engine. We want to use libfuzzer over here, and you can use actually any supported like AFL or hongfuzz, etc. as well over here. Then dash sanitizers, which is address. We are compiling using address sanitizer. Libtiff, which is our directory name or the project name as well, you can say. And this is the fuzzer which we want to run. So this is the fuzzer over here which gets compiled when we did build fuzzer. So now when we say press enter, we can see that it will start fuzzing. This is like our libtiff harness, and you can see if you have used libfuzzer, you will see that started fuzzing and it has used our corpus directory, and there are a lot of diff file. And let's wait for say a few seconds. If you want to cancel this fuzzing, you can simply press Ctrl C and it will stop the fuzzing. What happens if we like go again to build, and if you go to the out directory libtiff, so you will notice that I got two this OOM, that is out of memory crash over here. So this I got from my previous runs when I was testing it. And to replicate these crashes, what we're going to do is that we simply need to run this command, that is this fuzzer tiff underscore read rgp fuzzer, and followed by our like crashing input over here. So what happens is that once you find any crash or anything, it will be saved over here. Like you can see there are two crashes out of memory over here. So this is how you can fuzz open source software using OSS-Fuzz. It's very helpful, and I plan to continue this video series. We'll probably look at few other projects. I hope that this video has given you a general overview, and you have a very basic idea of what OSS-Fuzz is, what are the different directory structure, what is the project structure, and how can we use it to fuzz any library. Stay tuned for more such videos, and if you have not, please do like, subscribe, and share my channel. That will motivate me to create more such videos. Till the next video, stay safe, enjoy, and goodbye. Thank you.